Well, great presentation, Korneel. I really enjoyed it. This is Baoxia Mi from UC Berkeley. I'm currently an associate professor in the Civil and Environmental Engineering department. My research group focuses on studies on membrane processes for water purification and desalination. We also work on the applications of nanomaterials in environmental engineering. All right, Mike.
Hi, I'm very delighted to be here as well. Korneel, thank you for an interesting presentation with provocative ideas to seed what I hope will be a good discussion. My position is the director of the water program at the Center for Law, Energy, and the Environment at UC Berkeley School of Law.
Thank you very much, both of you, for entering into this discussion. I'm really looking forward to your questions. And so perhaps, Baoxia, you can kick off the discussion for now. Over to you.
Sure. My first question is, Korneel, you have talked a lot about this decentralized system. I really enjoyed your discussion there. I wonder if you could give a little bit more details on the technologies that you have in mind that could be used for this system. Like, what are the currently available technologies that are relatively mature that we could potentially use to put together the system? And also in the long run, like maybe 10 years or 20 years from now, the technology will further develop, and you might have some ideas on what are the future technologies will look like.
So I've been thinking a lot about that, because my standard answer would be like most technologies already exist. I mean, there's companies on the market that sell very small scale treatment technologies. There's hundreds of thousands of individual treatment units for homes, infiltration systems. There's less technology on the in-house activity like gray water, but there's also no companies evolving. And you even either going to see more like bioreactors, carrier-based, often. I'm thinking of companies like a Pure Blue, like a Hydraloop, or there's the membrane bioreactors that you put at smaller scale. The biggest challenge, of course, at these smaller and smaller levels, where there's two big challenges, is first one is the potable water supply. I mean, you have to make sure that you have qualitative drinking water. We have the technology for that, but it has to be economic as well. And if you have a source like rainwater, then of course it's wonderful to make drinking water. Actually, it's very soft and it's empty mostly. Mm-hmm. Although there's a lot we still have to learn about rainwater. The challenge there is going to be, of course, safety. Not that we cannot put a membrane there that would make safe water, but we need to be able to monitor. So we need sensors for an architecture around that. But on the long run, I think there's a risk of looking into these systems based on what we have at the moment. And it's going to take some creativity there I have no idea what it will look like in 20 years, but it may be very different. I think some aspects are going to be that is going to be very compact, obviously, and cost effective, logically. Likely it will be, of course, internet connected, the system of the future. But the architecture for sure will change. In the beginning, it's probably going to be more aesthetic than in the end, because in the beginning, you want to build nice systems that people want in their home and give a place. Well, after a while, it will probably be just like the electricity box in your garage or the gas inlet, the boiler for the heating. It'll be a system like that. The future is hard to predict in this one.
Thank you. So I'm thinking about the when we have a decentralized system, for example, in a household, we have the treatment technologies for the recycled wastewater, which probably, like what you said, involve membrane bioreactor or similar technologies. And then for the rainwater that we are going to collect and treat, I wonder how you are going to like manage these two different water resources, because just thinking about the seasonal change in different locations, in different places, I guess the recycled wastewater might not be changed or affected too much, but the rainwater collection and system operation will be affected a lot by this kind of climate or seasonal change. Do you have any comments on that?
Yeah, we've been, thank you for that question. So we've been looking into different options globally in our simulation. So what I've presented in my presentation is for Belgium, Flanders, and you may think it's a wet area, but actually the average rainfall in the past years was less in Flanders than it was in San Francisco. So we're also dealing with extended drought periods. Now, technically, it's not difficult to make a house fully water independent. You always have more water coming in. I mean, at some point, rain comes in or water at some form, and reusing gray water for toilet flushing and the like, you can do that at quite a high efficiency. Your limitation is psychological and accumulation of contaminants. And that's what limits the amount of cycles you can do. Recalcitrant organic matter, metals, the like, and the first one is salt. So what you do, what you have is that you hit quite quickly higher salt limits that make the water no longer usable. And that's what constrains how long you can be independent from a water perspective. But even with that, it seems that with, you know, if you install black water, gray water, urine source separation perhaps, and the rainwater coming in, and you have small buffer tanks that you can store the different qualities, and the system is smartly adapted with a small amount of buffering, you can actually be independent for a very long time. And this is what we're trying to make KPIs for. But we will also need to make decisions. Like if you build an individual grid, or you even go to home-based water independence, you may build it in a way that once every 5 years, you'll have to top it up. And then it'll be a decision whether that is fine or not, right? You need to take a decision. Maybe it's fine if once every 3 years, you need to top up tanks with extra potable water, because in the balance of things, because you didn't have to put a sewer and you didn't have to put a potable water network, that saves so much in embedded energy and in transportation energy, that you say, well, if once every so many times you have to bring in water, it's still a much better issue. But so technically becoming independent in most places is not super difficult. Of course, when you're in the desert, when you're Saudi Arabia, the story becomes different, because then there's almost no supply. But then you have to think of it differently, that the input is going to be desalinated water, and you're going to assess the quality of the house by how little desalinated water it needs, because it cycles around the water very efficiently. And that's also a kind of an independence. Maybe you have a village and they put a big cistern there with desalinated water, and if the village can deal with that for 3 months, that's also a form of independence. So it will take many shapes. But the overall seasonal variability had less impact than I expected once the simulations were through.
Okay, so I'm glad to hear this perspective on the from the water quality point of view. So how this continuous operational collection and usage of stormwater would affect the salinity, and that would become a factor that like kind of allow you to operate or predict how often you need to maybe discharge a certain stream or amount of the high salinity water that is accumulated in the system. I wonder from the the perspective of the storage, the total volume of the storage needed in terms of rainwater collection. Do you have any comments in terms of how big the storage tank would be for a small community or for a single household? Is that reasonable to have?
Yeah, it's very reasonable. Actually, of course, it's very reasonable if you have new developments or some space. But a typical simulation, the average size of a household in our areas is around 2.7 people. And for that, we did simulations with 5 cubic meters or 10 cubic meters of storage.
Okay.
And so is that a lot? It's not a lot, and it's actually already obligatory here. If you build a house here now, you have to have a rainwater tank, and it has to be at least 5 cubic meters. And the government is thinking of giving you a premium if you go to 10 cubic meters. It's doable, but of course, if you have a high rise in the middle of the city, that's harder. But honestly, systems like I'm describing here, you can wonder if you have a dense city, there's probably a good network. It's probably energy efficient. You have a treatment plant nearby. It would seem a lot smarter to have a good wastewater treatment plant with a water reuse that it sends back in the city than consider that in the city at every point you start making buildings individual. So I think the models that I was talking about, they would be much more suited for suburbia than for a central business district.
Okay, so for like 5 or 10 cubic meter, how long the water will last? For
it depends on the scenario.
Okay.
So if we take our average water consumption, which is around 96 liters per person per day, Belgium has quite a low water consumption in that perspective. You actually here you become with that kind of storage water independent quite quickly, because we still have rain. We generally don't have periods where it does not rain for more than a month.
Okay.
And if you say the average water consumption is 96 liters per day per person, but you have also a system that takes the gray water and reuses that for flush water. You get from the rainwater, you got your drinking water. You can quite quickly calculate like, well, I don't need very much. Your problem is more that you have to purge always. You need to get rid of water. You will much because of this contamination. And so actually the problem you bring from the supermarket, right? It's what you put in the water, the salts with the urine, and the other products that come in the kitchen. That is your problem that is causing a limited water closure in the house.
Okay.
But not the water input. Certainly rainwater is very low in organics. So we are testing at this moment in the lab different options for rainwater treatment with or without biology, but also with membrane reactors. Yeah, the concentrations are so low that it's rather a problem of the biology not getting so low. On the gray water is different though. It's a bit stronger than normal wastewater, and it comes with an advantage, right? It's stronger than rainwater, but gray water comes with a big advantage. That's why we like it a lot, that you generate it at the same time that you need water. It's when there's people in a building, you generate gray water and you need water. Rainwater completely disconnects from needs. right? It's independent. And so any system that thinks about closing water loops locally, we think that the first good step is to focus on the gray water and the urine. The urine for the nutrients and the salts to get them out.
Okay. Yeah. I guess the system would be kind of different in California, right? Because we could go for a few months in the summer without any rain at all. In that sense, we would have to rely more on the recycled water, having a much bigger storage tank.
Yeah. But as a membrane expert, you know that you could perfectly regenerate that water all the time in the home. But then it's a psychological issue that is going to be more into play.
All right. My last question is actually on the solar energy, because you did focus your discussion on the usage of solar energy as the energy input for this decentralized system. Do you think this is the most promising form of energy that we could use?
I think it's a very suitable form, because one thing that's very nice about water, it is actually very easy to store. And so as solar energy at the level of houses and buildings has its fluctuations, the advantage is when you have solar energy, it's easy to produce a certain amount of clean water and store it. I mean, your tank is a bit like your water battery, right? So you can store that water there. If you take a normal cycle, we think you need about 500 kilowatt hours for a family per year to close your water cycle. And 500 kilowatt hours is what you get from 3 square meters of photovoltaics. Can it be other energy? I've been thinking about that. The one disadvantage when thinking of energy is that we always think about energy as electricity. And energy is also heat. And so perhaps other inputs can come. But would you think of other sources to drive this?
Well, I think you got what I'm trying to ask. So because you mainly talked about solar PV panels, to use the solar energy as an electricity in the form of electricity. I'm wondering if you have in mind like other, like for example, using solar to heat up the water directly, or using the solar to for evaporation process that could be potentially used as a form of treatment as well. So I'm just asking whether there's other kind of promising input here in terms of how we actually use solar energy.
Yeah, I think I like your thinking there. Indeed, I mean, we can generate with the photovoltaics also the heat, evaporate, distill. The heat makes me think also on an approach that the Gates Foundation has been looking into with Jose Torero, these smoldering approaches. If you have concentrated flows like with fecal matter, you can actually separate out the organics and burn them very slowly. And it's such an efficient incineration process that you can actually ash residual organics. I'm not saying it's going to generate a lot of energy, but of course it's a way of using the energy that is in the organics to deal with the stream. The advantage I see there is that in the end, the metals and solids, phosphates, the like, are going to end up with this solid stream. And if you burn it, all you have left is an ash. And now this ash contains my phosphates and my metals. So if you think of like, well, maybe this is a new opportunity to also start thinking about recovery. Because now now recovery, it's a fight against entropy, isn't it? We throw everything together. We have beautiful urine with a couple of grams per liter of nitrogen and more than a gram of phosphorus, if it goes well. And then you dilute it down. And as a result, you have a more dissipative approach to deal with the problem. While if at house level, you would ash, and the garbage collection happens anyway, right? The truck passes by. If every now and then you throw that ash into the household waste, which is going to be incinerated for a long time still, we separate here in Belgium the plastic, the metals is all separated out, the glass. So we have really residual waste, and that is being incinerated. And from those bottom ashes, they're already looking into recovering phosphates and metals. So you could think of new pathways of maybe from the homes, you can just throw the ash with the waste, collect it. So there's a lot of different energies there, but I take your point that we could do more, perhaps with photovoltaics or other sources of energy, to make it also more robust.
Exactly. Thank you so much. I do want to give some time to Mike so that he has some chance of discussing some questions with you.
Yeah, terrific. Korneel, I enjoyed the presentation for its visionary nature. And one of the things I wanted to start with was innovation, because that seems like it's a cornerstone of your answer, in some ways explicitly, to the question of how do we get from where we are now to this vision of an extraordinarily distributed future for water services. And one of the parallels is to electronics industry. And so a lot of the rapid innovation in that sector, it depends on silicon, and the fact that Moore's law predicted and has delivered a consistent exponential growth in the performance and cost reductions of semiconductors. So we haven't, so far, to my knowledge, seen that in many or any areas in the water sector. And so I wonder if you could reflect a little bit as a technologist about why that has been so slow, and what might change to make it different in the sets of technologies that you're envisioning for this distributed water future.
Yeah, it's a very good point. I like Moore's law for its simplicity in a way, and still being quite true. Now, if you look indeed long term at reverse osmosis process, for example, you really have these decay function in costs, energy investment per unit water that is treated. But it is slow. It takes decades. And so one of the explanations I also discussed is one of the reasons that is slow is just that typically infrastructure is very large. A centralized infrastructure takes a very long time to build. It's a very serious decision before you go into building a new treatment plant. And so small scale distributed systems, they're much smaller decisions, certainly in a transition period. And of course, once you have a network of such or a high presence of such distributed systems, the decision is only to build the next small one, which becomes a small cost. So that is it in part, but I think also that in the water sector, we have not been challenged enough in thinking in rapid innovation patterns. It could be maybe a lack of competition. It used to be a state-governed thing. The biggest water companies in the world historically were Suez from the Canal, Veolia, big French classic utility-based companies, and that drove the water sector. And it's very different than what you see in the IT sector on the dynamics of companies, where there's also a lot of creativity. And I think the slowness is also caused a bit by a lack of creativity that we have as water researchers. And I started reading up a few years ago on this sunk cost effect, which I find great. And I don't want to be too anecdotal, but a local professor gave us an example, like, let's say you have a very thick book and you start reading this book and you're halfway and you realize it's a terrible book. Most people are going to continue on reading because I've gotten here, I'll get to the end. And so the sunk cost effect plays very much in researchers as well, because you invest a lot of time in focusing on a sector, large installations. This is how it works. This is how we remove nitrogen. You become an expert, and then as a result, you really are geared towards these kind of developments. The difference in the electronics sector is that their product is very intimate, very close with the user, right? Not the message in a way, like water. The water is also intimate with us, but the technology to make that water is very far away. And if you would bring technology closer to that user base, you would really tap into that creativity. And I think that will have also an impulse there. Now, will we get a Moore's law on water? My answer is I don't know what it would look like, because it's not like a transistor that would, or a processor that would double capacity every 2 years or so. You know, I can't imagine like from water treatment becoming more efficient every year with a certain rate. There's a law of, well, at some point the water is clean enough there and that's it. But it could be cost, or it could be number of units that follow such an approach. And in that, very much under the radar in Europe and the US probably is what I also showed in my talk, these under the sink RO installations in India that are now very cheap. And of course, they don't need to do much. You go from a water that you don't fully trust to a water that you fully trust with a membrane. But it is now possible to make that membrane, package it, get it to customers, whatever, of a price between $200 and $300. So, and why is it so low? Of course, because they sell millions of it. And so we could be seeing a type of a Moore's law in either cost factors or either quantities, but probably not in a feature like performance.
Well, what you said suggests that to me that we may need to find an Elon Musk for the distributed water technology sector. And there's at least two things come to mind. One, which I think you sort of anchor your model on, is the way that he started with focusing his efforts to produce electric cars as a luxury product. And he's explicitly has the strategy then of letting what he's learned from that eventually move down to something that's consumable in a more mass consumption way. The second thing that occurs, and I'm not sure if this is an urban legend or not, but I've heard said that that Tesla would either refuse to hire or severely count against someone experience in the automotive industry. So really? Coming at it with fresh eyes has enabled him to make something that looks like a car from the outside, but is very different than any other kind of car that's been produced, down to the way it functions and new functionalities and so forth. So we got to find that person.
That's great. Imagine founding a water company and deliberately not hiring anyone aware of water.
Automotive experts.
yeah. But it makes sense because I admire a lot what they have done, because they're really redesigned while all the others are adapting. And adapting starts from what's there. And what you see in the water sector is often you come on a wastewater treatment plant and you think, my God, this is complex, so complex. But it's just because they started with something and then there was an extra requirement and the city grew and they put on an extra tank here, but they didn't have space, so they put something else. And after a while, it's a network on site that you wonder, what is this? And so if you have fresh eyes, it's a good idea to look at it. And the model is also right. I mean, photovoltaics, cars, the same. You look for a willingness to pay with affluent people who also want to be recognized that it's a visible technology. And they pay, and they know they pay too much, but they don't care. They pay for it because they're contributing to the development. They have the feeling that they contribute to something. So we will first have to convince people that by doing such decentralized treatment, they can contribute to sustainability. And we will have to factually show that with numbers, with CO2 emissions, with land use, with important parameters that they can truly say, look, if we do this, this will be better. And then you have to think of how to move this across in a way that it will be attractive. And this is why I would mention things like health promoting or flexible or adaptive. The behind-the-counter services that are starting to emerge in places in the world as well, the water taps, the in-house, the soda streams going from the Brita filters. So you need a product that appeals sufficiently. And so if you can show that, of course, we agree that the quality of tap water in general in developed countries is fantastic, and 200-300 parameters are measured on this water, and we remove trace contaminants. But it's not intended to go a step further and, for example, try and to beneficially steer your gut microbiome or your skin microbiome or your dental microbiome. And so if you can do mineral interventions that work on osteoporosis or do small other interventions with bacteria or pre and probiotics that are health promoting, then you come into a different story. That's the different category I think we're looking for. And this doesn't need to be visible. It just needs to be an established effect. And I think that would be I think that would have one of the highest chances of introducing this besides just visible sustainable technology, preferably on the roof. So everyone who passes the house in the city can see, this person is working on sustainability, right?
Yeah. Well, just to draw
sorry
on that.
to jump in. Since you're talking about this system, I'm really excited to hear this. But just thinking about, it's not just from the sustainability point of view, but at the same time, there could be economic benefit for the consumers as well, right? I'm just thinking, like in California here, the water bill for residents could be so high in the summer because like if you use a lot of water for irrigation in the garden or in for your lawn, it really could cost you like hundreds of dollars per month. And if we could have a system that reuse the water that people used for irrigation in the household and make the system manageable, like not too much maintenance and not too expensive, there could be a real market for it.
Yeah, I agree. Low maintenance is also important there. We already forget to put a bag of waste outside in front of the door once a week for the truck to pass by. So it has to be quite independent. People also don't want to deal with waste. Imagine you have a building, 20 apartments in there, and you have to collect the nutrients from the urine. I mean, that's not a very favorable proposition if somebody living in the building has to do it. I mean, it has to be, like a phone at most, you have to accept that it shuts down every now and then because it's getting an update, but you don't want to be bothered by having to go and change something in the apps, right?
So I would jump on. There's a lot of themes here that I'd like to pull apart a little bit. One relates again to the Elon Musk story, and I'll say first that I may be your target consumer. As soon as I bought a house, one of the first things I did was run and install solar photovoltaic panels on the roof, not because it was a conspicuous thing, but because it was felt to me like the right thing to do and an important contribution to the world. So one thing though about Tesla and many of these technology companies is that they depend very deeply on enormous amounts of capital to get started. Tesla only very recently started to have profitable quarters after billions of dollars of input of investor funds. In the water sector, currently in the US, a seven-figure round of investments is seen as a pretty large one. 8-figure ones are pretty rare. So we're off by some orders of magnitude in comparisons with these other industries in terms of available capital. Do you have a sense of how to pencil out the potential profitability such that this sector could draw the necessary capital to enable that business model to move through this transition period?
Not really. I'm not an expert in the economics. I mean, I do see. I mean, like a car sector is not a hyper profitable sector, but I guess it has a long-term perspective that makes investors go for it. I would not underestimate the amount of money that goes around in water, but indeed, typically startups in water are pretty poor startups. They start up rather small. They typically have to do a lot of consultancy to make ends meet. It is a sector that is less appreciated by investors. I think it is also in part because there's little things coming on the market that are really new. We have interesting sensors coming. We have interesting materials coming, but there's no electric car that has come in the past years, right? I like new systems that are practical and fast. It's like the Nereda system from the Netherlands. It's nice. It's a more compact water treatment. But I always ask the question there, or like with Anamox. Anamox, you may not be familiar with it, is a nitrogen removal strategy from water that uses less energy. It's very nice, but it's not where you want to be in the end. It doesn't make dream of this very magic solution, this entropy dissipating solution that gets that nitrogen out of the water and brings it back as a product. So I think in part, incremental developments lead to probably lower investment because it's not, you cannot see a path that is going to revolutionize in a way that everything else goes to the side. On the other side, it's the ideas and the appreciation. The final bit is perhaps also, if you look at venture capital and the like, and you talk to I've talked to many people in venture capital funds about water. You have venture capital funds on IT, you have them on pharma and biotech, but on water, they don't really exist. So I guess the sector also doesn't really exist, and that also adds to this.
Yeah. Well, I would suggest then that there's another way to think about this, which is that instead of thinking solely from the perspective of this model of innovation that we're talking about, whether it's Elon Musk or Steve Jobs or whoever in these luxury goods markets. Think about the potential that there might need to be a step change in the demand for these products. What might stimulate a step change in this way? Well, we're talking about a sector that currently is so dominated by the public sector, and so one of the ways to think about this is not purely from a market and innovation approach, but from a policy approach. To what extent can your vision be articulated such that it's clear that it would be in the larger public interest? And if so, is there room for policies that could dictate, for example, certain types of development would need to be off-grid in particular ways? So if there's a new suburban development, instead of the standard method of hooking it on to an existing service system and expanding the service area of a water district, think about certain densities and certain areas being required to have their own independent water system. That would stimulate the need for this type of system being actualized in practice. If that was something that could be widespread enough, then all of a sudden you've got a demand signal. Because with population growth and development, these venture capitalists would be able to pencil out how many new systems would be necessary. Then you've got your capital flowing for startup. Of course, I'm making a just so story up, but the fact that you had a fairly light emphasis in your presentation on the policy side suggests that there might be a way to hybridize the institutional approach that you're thinking of, and leverage the fact that water still is in the public domain, even if we have a vision for a transition that at least in part depends on private sector investment and innovation.
Yeah, I find very interesting to indeed think about, how can a government indeed incentivize it? It makes me think of the San Francisco intervention, where they say, well, now a building has to have, if you have more than, 300,000 square feet, you have to have water reuse on site. And that has driven a lot of new technology developments in the San Francisco area because there was a need. You could similarly say, like, look, if we have to, that society, that the full costing of connecting your house will be charged to you, which it is not today. I mean, it's interesting here, like we have terrible urban planning in our areas, and we know that it costs up to about 16,000 euro per house to connect it to the sewer and the potable water grid. So that's about $20,000. It's not a small amount of money. If I think of water technology, $20,000, if you do that for an area that's a bit remote, as you say, and that the government says, look, we're not going to connect this up. Either you have for 100 houses, you find your own local grid. We supply this. If there are places where these kind of decisions are made, of course, that will very quickly drive technology. And if the government then at the same time also incentivizes that, logically, by saying, look, this is a new guideline, but in the beginning we'll give you a subsidy. But then that will create market, and companies will come with solutions that are cost effective. It can happen today. There's going to be a nice case study, so I don't want to spill the beans, of one of my colleagues of an almost water independent or a water reuse scheme in the city of Ghent, where the water of about 1,500 people will be fully reused, where they closed a lot of loops. And what I hope he will show you also in a few weeks is that this can be economic. But with a challenge, of course. If you do this near a city, in a city there is already a sewer, you're not using the sewer. So should these homes still be contributing to the costs of the existing sewer? You have new challenges there. But at that point, a bit as you say, it's legislations, it's decisions by society of how you want to do it that are going to drive it.
Yeah, one financing model that could provide some kind of analogy here is based on the knowledge that there is an income stream already in terms of water and water-related services to homes. At least in concept, people already pay water bills and they pay for sewer system upkeep and so forth. And if new housing developments were built without those things, there's no reason that there would be need to be the expectation that some amount of monthly bill needn't be expected. There are schemes such as property assessed clean energy PACE schemes that depend somewhat on this notion of an expected energy bill that can be used to finance things like rooftop solar photovoltaic panels. So the potential there to access what's already there and what's already expected in order to make the change could be done from a financing perspective as well.
So I have a question for you there. Like, do you have the feeling that where you are, that people are actually paying the full costing of the water? Or that there is a lot of hidden cost essentially of water that because here the water bill doesn't fully hit people. Costs like sewer networks are organized via taxes in part, and so actually the full costing of water is not really charged to people. And I think in California it's also the same. The bill you get is not the full cost of the water.
Well, I think this actually depends on where you are, even within California. And it depends on how you define the full cost of water. In some cases, yes, water services are subsidized by other taxes. In other cases, it's actually the other way around. And where some wealthy communities, water bills are fairly high, they subsidize other parts of public works departments. However, what we haven't talked about here very much, and that is very interesting for your model, is the fact that water provision has tremendous externalities that aren't accounted for in the costs that we actually pay in our bills. Those include environmental impacts of water withdrawals from streams and transporting that water. They include the environmental impacts of discharging the products of treated sewage, even if it's because it's often not treated to be completely pure water. There's nutrient pollution and so forth. These impacts are not accounted for generally, except in some nominal ways in our water bills. But your scheme would avoid many of those, or at least minimize them or change them in certain ways. So how to bring a triple bottom line approach could change the economics of what you're talking about. Again, if it were possible from an institutional and policy perspective to take a holistic view of water provision and water-related services as a whole.
I really like that idea that you mentioned here, that basically decentralized systems are a way of avoiding externalized costs. I have never thought of it that way, but it's very elegant. Yeah. So I'm being a bit time aware. Perhaps, Mike, it's incredible. We could go on for a few more hours. how about you pick one more of the questions for this debate, so we keep the package a little bit under control to put online, and then we make a deal that that we all meet up without the audience then to discuss further in the future.
That sounds great, and I think this conversation is one where the answer to each question generates several more new questions. So we could indeed go on forever. But I think the one how to pick from my many questions. I'm curious about risk. Can you maybe talk a little bit about whether you've thought about how the risks from transitioning to a new system would be distributed among the consumers of the system, among even the producers of it, and how those could be managed? I'm thinking maybe one place to start with is the risk to water quality, because you know, the risk of you buying a mobile phone and it doesn't work, well, that's an annoyance. If you distribute 100,000 new water treatment systems, and after a few years you discover that they have failed in a way that you didn't understand, well, we've seen exactly that happen, and there can be tremendous consequences, and we've had that even happen in the United States recently.
You're fully right. I mean, the first and foremost purpose of our water system is to safeguard human and environmental health. And this is where it starts. So risk on these new systems has to be managed very carefully. Now, everything has a risk, of course. Also, a smartphone, the battery can explode. And it happens very rarely, but when it did happen, it became a global issue. And so if we would produce a potable water system, I mean, let's agree the risk on grey water reuse for toilet flushing, we're probably pretty well there. But it's really about the potable aspect. It's going to be very important because for a nascent new technology, there's going to be some failures every now and then. However, I think that there's a lot of experience on water treatment already, and that the basic technologies, if they're not dramatically changing, like the UFRO membrane that we are already using to produce potable water, if you don't in the beginning mess around too much with the base technology, then from an individual risk perspective, it should not change much. But you will need good standards, ISO standards, and regulatory standards for the systems that can go on the market. And it's also a point that I'm not very worried about, because in your house, you have a high voltage line of electricity coming in. If you tamper and you start touching it, you can kill yourself. And if you decide to tamper with your natural gas line coming in and you blow yourself up, well, you know, it's a risk. But you're not supposed to do that. You're not allowed to touch the electricity or the natural gas. So you're also not supposed to tamper with your water treatment system in the same way. So you need to standardize it. But I think, of course, the advent of the Internet of Things does create opportunities to immediately also track, monitor. So one of the challenges for the technologies towards the future is to make affordable real sensors or soft sensors that are sitting there at these installations and that give a signal somewhere to an operator that an installation is malfunctioning. And I think this will also be de-risking massively, because every now and then a large treatment plant fails or a water line bursts and a whole area is without water. But we were talking just before on water treatment system at home level that basically your water is stored in a tank. And so if something goes wrong at the treatment system and you have a sensor that measures the pressure loss over the membrane, oh, there must be a hole, or the conductivity is wrong, like, oh, salts are coming through, the system can switch off and that single household still has maybe 5 cubic meter of potable water, and the repair by the company that comes in is only for an installation at one house. I would call that de-risking at a grand scale. You cannot have a plant for 10,000 people failing. Not that that often happens, but floodings do happen, creating massive infrastructure issue if you have a wastewater treatment plant that floods, for example. So there's going to be a risk at these small new technologies, but the impact of a failure of an installation is limited to a single household that still has a 5 cubic meter of buffer sitting in between the failing installation and themselves. That, of course, excludes if we go with a completely new, unproven technology for water treatment that works with principles that we are not thinking about today. But on the current technologies, I would think that it may turn out to be safer than the other way around. No piping network where you have contamination, correct? No lead pipes from historical buildings. No breakage of a sewer, no misconnections in systems. So there are a lot of aspects to think about there. So I hope this poked a little bit for further conversations. We could probably go on for a long time because we haven't talked about equity in these things. We haven't talked about equality, how these systems have to support those who are less affluent, but I think that's for a future conversation. So I want to thank you both a lot for a very interesting debate. I really think this has enriched the webinar a lot, and I look forward to questions coming from the crowd and future interactions with you both.
Likewise, thank you.
Thank you. Bye.
Bye.